Okay, this question that we're going to try is going to explore applying different concepts in one question. So it's really a power-packed question. So probably the concepts that we're looking at would be equilibrium, turning effect forces, principle of moment, and even Newton's third law, right? Okay, so let's read the question first. So you may pause the video to read it, or even try the question before listening to this. Okay, now, first thing first, when you read the question, so step one is to notice all the information, all the little hints given in the question. So as you can see, we have uniform beam. So this is a very useful info. So uniform beam tell you that this purple beam is actually uniformly, the material made is such that it's uniformly distributed inside, whereby the center of gravity is at its midpoint. So what if it's at the midpoint? The question also said that it's pivoted at the center, so which means that imagine the pivot is directly below the center of gravity. And which tells you that when you draw the weight of the beam, it will pass through the pivot. So the perpendicular distance between the pivot and the weight will be 0. So the weight does not produce any moment. So that's a very important thing. So even if the question, in this case for part A, we probably don't need to consider the moment produced by the weight. So, and the question says that the beam is at equilibrium. So what's the meaning of equilibrium? So in physics, when we say equilibrium, it's something to do with being balanced. So for something to be balanced, there are two conditions. So we need to put them into very tangible conditions so that we can use it in the question. So equilibrium means that the resultant force acting on the beam is 0. And the resultant moment of the beam is also 0. So when they say resultant force acting on the object or the beam is 0, means that the forces are balanced. And also it means that, so for resultant moment, it means that the clockwise moment is equal to the sum of anti-clockwise moment. Okay. Now we're going to apply. So in this case, we're going to apply the resultant moment of the beam is 0. So part A, we're going to look at all the forces that's shown here. Now, we have 9.5 Newton. So you can see that, so just imagine how does it cause the beam to rotate? So since the pivot is here, okay, so 9.5 Newton on the left and the 9.5 is downward, it will cause the beam to rotate anti-clockwise. 3.5 Newton will cause the beam to rotate clockwise. 8.5 Newton will also cause the beam to rotate clockwise. Okay. Now let's take a look at, so we have two sets of clockwise moment and one set of anti-clockwise moment. So let's get on to solving the question. So using the idea that the resultant moment is 0, which is the principle of moments, the sum of clockwise moment is equal to the sum of anti-clockwise moment. So for the clockwise moment, we have 3.5 Newton producing that, as well as 8.5 Newton. So let's put it in. So for 3.5 Newton, it is 0.3 meters away from the pivot, and this is your perpendicular distance. Okay, so I'm going to calculate 3.5 times 0.3. That will be my first set of clockwise moment. And the next set of clockwise moment is produced by 8.5 Newton, which is the distance d away from pivot. And this happens to be our unknown. Okay, so let's put it in. 8.5 times d. Okay. And your anti-clockwise moment is due to 9.5 Newton. So we have 9.5 multiplied by the perpendicular distance between the force itself and the pivot. which means it's 0.5. So D is, okay, so when you use your mathematics, you will get 0.435 meters. So this is in 3SF. So alternatively, you could also leave your answer to 2SF, which is 0.44 meters. So this is just a matter of presentation, because you notice that the question says 0.20 meters, which means 2SF sounds like a good idea too. Okay, now part B, we're going to use the idea that the resultant force acting on the beam is 0. So which means all the forces are balanced. So before we even start working, we need to know what are the forces acting on the beam. So let's just draw a quick sketch of the beam. And you have 9.5 Newton. You have 3.5 Newton acting upwards and 8.5 Newton downwards. But that's not all, okay? So because some of the forces are actually acting but not drawn on the diagram, but we have to know it, okay? So the beam actually has a weight of 12.4 Newton, and there is also a force exerted by the pivot on the beam. So imagine the beam is resting on the pivot. So the pivot is going to be pressing on the beam. So we're going to have this force exerted by the pivot on the beam. Okay, yeah. So now, since the resultant force acting on the beam is 0, that means all the upward forces must be balanced by the downward forces. So let's say 3.5 Newton plus pivot on the beam is equals to 9.5 plus 12.4 plus 8.5. So using your math, you will get that the pivot, the force exerted by the pivot on the beam is 26.9 Newton. Okay, so now, are we done yet? Let's come back to look at the question. It says calculate the force acting on the pivot, not acting on the beam. So how is this answer related to what the question actually wants? Now let's recall Newton's third law. So Newton's third law says every action has an equal and opposite reaction, which means that the force exerted by the pivot on the beam is equal to the force exerted by the beam on the pivot. So that's how it's related. So since the force exerted by the pivot on the beam is 26.9, so the force exerted by the beam on pivot is also 26.9 Newton. So this too will be your Newton's third law, the concept of using your Newton's third law. Okay? Right, so I hope this is useful to link a few concepts together. If you're not sure, please watch the previous video, yeah? About moments. Thank you.